Thanks, everybody. I'm going to give just a couple of context setting slides, and then Joe is going to share a lot of like how we've been using VisionEval to address some of our legislative requirements. So just to give a quick run of show here, what we're going to just cover is what we're being asked to do here in Minnesota. There's going to be a lot of parallels with some of the work happening in Oregon. We are going to talk a little bit about how we came into the use of VisionEval, and then the overall setup that we have for evaluation. So to try to just boil this down a little bit into a couple of key components, in 2023, our legislature identified a priority to reduce emissions across each sector. And so there was a lot of focus around what could be done in the transportation sector, and in particular, what could be done to be more accountable for emissions reduction in the sector. There was a couple of key requirements that were put in place. One was for us to start to evaluate emissions reduction at a more granular level and better understand system outcomes on a regional basis. And we'll get more into that, and also kind of how VisionEval has been a useful tool. We also, number two, were tasked to be offsetting any capacity expansion that was happening on the highway system. Folks are probably familiar with California and some kind of similar requirements around evaluation and assessing impacts and looking at induced travel effects from highway expansion. And so that's like a key requirement. I'll touch a little bit on this, but a lot of our focus is going to be on kind of more of this programmatic evaluation. And then as we look ahead, what we're really being asked to do, what we're being set upon, is to evaluate emissions outcomes in a programmatic way at key stages of our planning, program, and project delivery process. So what we have is, I just saw a notification. Can folks not see the slides?
Looks like we are having one or two people with trouble. So if that is the case for you, please sign out and try re-entering the meeting.
Because I think most people can see it.
Yeah, okay. I think you're mostly good, Chris. Yeah, we'll see if folks solve their problem by exiting and entering back in.
Okay. Here's just kind of a process flow on some of the things that we're working on, and want to draw your attention to a lot of what we're being asked to do rhymes with some of the work that you all have developed with this storm analysis and that overall process. And we want to just thank, I'm sure a number of folks on this call were directly involved in that process. We have developed a lot of insights from the work that you all have done in Oregon, and are looking to sort of apply a lot of that work. And so, but what we're being asked to do is really evaluate emissions impacts at these key stages. And right now, what we have in place is the emissions evaluation on a regional basis, which VisionEval was used to provide. And then we also have project evaluation that's happening for projects that expand the highway system, and then requirement to offset those impacts. Happy to answer questions about that, but we're not going to kind of spend too much of a focus on it. Into the future, we're looking to integrate emissions evaluation more directly into our plans and also into our program and project selection. And that's kind of a key focus for us over the next couple of years. And another area that we're going to be drawing from you all quite heavily. So don't want to try to oversimplify this, but when you think about surface transportation emissions, there's really these two key drivers. When you look at the fuels and the carbon intensity of the fuels that we are putting into our vehicles, and the miles or mile rate that each of us are driving in our respective states. And these are, kind of the two key levers. There's a lot going on underneath the hood, and we're going to get into that with VisionEval, but this is sort of core to what we were being asked to do. And Joe, if you want to go to the next one here, one of the things that really drew us to the VisionEval work was the opportunity to delve into a pretty difficult topic around identifying whether or not emissions reductions could be quantified from the relationship between modal options and land use choices. And this is why we saw the VisionEval tool as such a valuable thing in our process. And Joe's going to kind of get into a little bit more of the detail, but that's a little context setting on kind of why we came into it the way we did.
Yeah. So thanks a lot, Chris. Yeah, so just to start off, just want to give a little bit of a background on VisionEval and discuss a little bit more about the decision-making process to use it. So first of all, VisionEval is an open source modeling framework, which means it's quite easy to edit code and rebuild parts of the model, as well as to find help too. It's also strategic in nature. It finds answers to big questions and is able to look at policy level approach, especially to some of the larger policy decisions that we're trying to make, whether that's electrification or greenhouse gas reduction. It is a higher level of analysis for sure. So like some of the more like specific and like maybe parcel level stuff is not as included, but it is also much quicker to run, like a travel demand model. You are also pretty like able to use multiple geographies as well as aggregate up and down for this state, all the way up to the state, all the way down to the census block. You could probably do multiple states as well. And then finally, the queries are a really great way to unlock the results, and those are done in the post-processing side. So the queries make this model highly customizable in post-processing. Yeah. So then to kind of like reiterate a little bit about what Chris said about what we were asked to do, is we really wanted a model that could help us evaluate baseline future greenhouse gas emissions in 5-year increments, because that's what the legislation was pushing for, as well as looking at regional feasibility for reduction, knowing that we are a big state with a lot of different settings, geographies, and demographics, and as well as evaluate different mitigation policies using VisionEval's scenarios. And specifically the 7-county Twin Cities metro area, the Minneapolis-St. Paul metro area, must be evaluated on its own in this. So in order to do this, we wanted to break up Minnesota's geography into 3 different types. So there's the urban, town, and rural, which is native to VisionEval, that sort of breakdown. And we also used some geographical classifications for that storytelling side of it. So we use counties, which are called A zones in VisionEval, as well as the Minnesota's 8 metropolitan areas, and those were each given the M area title, is what those are called in VisionEval. And then finally, the outputs are going to be tons of CO2 equivalent, as well as vehicle miles traveled, were the two outputs that we are the most interested in, though there are definitely others as well that come out of VisionEval. So then the next slide, I just want to talk a little bit about like how the steps to get the model up and running the data used as well as running the model and the output. So it all started really by breaking up Minnesota into those geographies in order to take into account like urban-rural divide as well as just different geographical settings. And then we wanted to use a very large host of different data sets from the Energy Information Administration, Federal Transit Administration, Census Bureau, as well as some Minnesota level ones to get as accurate of a picture of current and future greenhouse gas statistics as possible. And then three, the VisionEval is very intuitive to set up in our studio. So we would set it up, we would run the model, we would repeat until we got like all kind of like the error messages finalized, which there are quite a few of those if you've worked with this model before. And then we also had an opportunity to rebuild some of the internal modules as well. And then finally, you run the results using like a query code, and then you can get metrics for VMT and greenhouse gas for your geography. And that's what we ended up doing right there. And a little bit about how we broke up the geographies. I just want to flash this slide real quick that there was definitely like a concerted effort into how we did this based on population as well as the different boundaries, knowing that there's a difference between like the metropolitan organization jurisdiction and the urbanized area. And that's what this slide kind of breaks down. And if you have questions about how we did that, we can also cover those later. And then kind of just bring it back to the legislation. It was really important that we looked at regional feasibility and we looked at the differences between different regions. And we had a couple of different approaches to do that, to break up the data, including one that is really just the Twin Cities and Greater Minnesota, one that's Twin Cities, the 7 other MPOs and Greater Minnesota, or the Twin Cities, all the 7 other MPOs, and then breaking up Greater Minnesota, the rural areas, into our 8 MnDOT districts. So I just wanted to show that, to really just show that like the ability to be geographically, have that geographical context is really a plus of VisionEval. So then we had to get some of the model inputs going. And what the model inputs include are demographic data to kind of give you a feel for the people that use the transportation system and where they live, the family size, a lot of stuff from the census, US Census Bureau. And then travel data was also used in order to see where people were going and how they're getting there. And then land use data was used to kind of give some of those locations meaning, whether that's where people are employed, or I'm saying that this is out of order, maybe. Yeah, so, but anyways, I can still take it from here. The land use data also included like multifamily housing, as well as activity centers. And then power, fuel, and vehicle data. So after you have kind of like that sort of travel inventory, how the vehicles are powered, what type of vehicle was used, was really helpful for the fuel portion of our scenarios. And then let's talk about running the model. After running the model a few times, we realized that VisionEval's projections and our projections for future electric vehicle adoption did not necessarily line up. So we were able to fix this by rebuilding the VE powertrains and fuels module using our studio's build features. And from this, we were able to input our own market share predictions from our electric vehicle infrastructure needs assessment. So I just wanted to show you kind of like the customization of this model using this, and this produced results that were more in line with the electric vehicle needs assessment. And then finally, the results were quite interesting out of this. Looking at this one in particular, we still have a gap even after all of this. We see that the gap then gets quite wider from our goal to be net zero by 2050. But kind of like having this baseline was quite important. And now we can kind of discuss and think about how we can reduce that gap. And that's where the capabilities of VisionEval's scenarios come in. So the orange dotted line is the forecast from VisionEval, and that gap is that purple shaded area. So kind of going back to one of Chris's slides, we know how transportation carbon emissions are produced. But what we really want to find out are how much would our interventions lead to a lower carbon output. So in order to do that, we wanted to break up some of those inputs by levers. So here's a list of some of the potential levers that you can look at. These are all inputs into the model, but VisionEval has the ability to have separate folders for scenario inputs, and then the model will run the scenario inputs after it runs the baseline. So you're able to change those fairly easily. And then using those levers, as we called them, we then paired levers kind of asking the same question or trying to answer, trying to find the same objective into scenarios. And then scenarios are quite easy to change. They're really just a CSV file as an alternate input. And we wanted to both test running the policy groups, so connected growth, transportation options, fuels, separately, just to see the outcomes that those separate tactics would provide, but also run them together, change around like the intensity of them in order to get a really good idea of what the model can show us and what these outcomes could be. And I think that like the number one thing that I took away from running this is that the compounding the scenarios together had produced exponentially higher results. The context that you get from not just expanding mode shift, but also expanding mode shift and having more walkable areas and more mixed use, as coupled with like the fuels, for example, really produced higher carbon emissions results. So that like coupling of scenarios was quite interesting to us, that it needs to be a multifaceted approach to lower greenhouse gas emissions. And then we also learned about what is possible for our scenarios by doing a robust stakeholder outreach, whether that's with the subject matter experts or with regional partners like our MPOs to get regional priorities and possibilities. And we also had some great best practices from ODOT and Washington DOT, who were on the forefront of the VisionEval modeling process. So to end with some lessons learned, I love the quote, "All models are wrong, but some are useful." And I think that this model has been extremely useful for us as a strategic tool. It is important to also often remember that it does not consider smaller geographic variation as much as some other models might, but the quickness and the ability to ask multiple questions, I think, is something that makes it quite helpful. And then, like I said, being able to customize it and fit the model to your data and your region was also quite important for the greenhouse gas aspect of this. Want to reiterate again that those scenario levers are produce exponentially higher results when they are combined, because you get kind of both of the context from land use changing because of transportation options expanding, or vice versa. So combined, the change is quite high than running them as separate scenarios. And then building an understanding, I should say understanding, that's a typo, my bad, with stakeholders is also quite important to understand what is and what is not possible in the model, and to explain the inputs of the model. Really happy that we did quite a lot of that. And then finally, just whenever you run multiple scenarios at the same time, it is going to add time to your model. Once again, that's not, or to the model's runtime. Once again, it's not, it might add like a 45 minutes to an hour or so, but quite less than like a travel demand model, for example. So yeah, that's what we had for you all today. Thank you all for listening, and yeah, special thanks to everyone that helped us get this model up and running. Very happy with what we were able to do with it.